in 5, 4, 3.
Hello, everybody. Welcome to STEM for Success's STEM in Your Home video presentation. I'd like to thank all of our live viewers for logging on during our crazy blizzard to watch our videos, as well as any of the viewers that are watching our live stream after it was posted. So today we're going to be showing 2 videos in our STEM in Your Home kitchen series. And then after our videos, we will have a follow-up Q&A with all of our STEM mentors. Joelle's going to talk a little bit more about how you can submit any questions during the presentation.
Thank you. So in the description, if you're in the YouTube page, there should be a link to another detailed event page. And then in that document is also a Google form, which you can fill out. It'll ask you what questions you have for us. All you just have to do is just type in your question and we'll answer it afterwards.
Great, thank you. Okay, so before we jump into our videos, we are going to start by introducing ourselves as the STEM mentors. So I'm going to go first. My name is Natalie Wilson. I'm a second-year chemical engineer major. I chose chemical engineering because it combines 2 things that I loved the most in school, and that was chemistry and physics. So I started working for STEM for Success in November of 2019. And in the beginning, some of my main roles were going to STEM clubs and helping assist them. But with COVID, now one of my main responsibilities in STEM for Success is creating the STEM in Your Home videos. And being a mentor for me has been such a great experience because whether it be showing videos or going into physical classrooms, I feel like I'm able to really give insight in what STEM feels like as a woman in STEM, and hopefully to help break down any barriers that might be preventing people from going into STEM. So Joelle, you can introduce yourself next.
Hey everyone, I'm Joel Heredia. I am a 4th-year mathematics major at NJIT. I chose mathematics because I liked the subject since I was probably like in 2nd grade. I think mathematics is a really cool tool to use in the world. You can use math in many things out there. Why I started working for STEM for Success? Well, when I started working about a year ago in 2019, late 2019. I met Bruce and Jim way before then. They were great men, great people. I liked what they were doing, and I enjoy helping out students with STEM activities. As a mentor, we go out to schools and we go out to clubs, and I like to help students facilitate their interest in STEM and teach them my insights on the subject. Emma?
All right, hi guys. So my name is Emma Hamza. I am also a sophomore student in chemical engineering. I chose chemical engineering because I like all the different applications it can have and the versatility of the major. You can go into pretty much in any field with a chemical engineering degree, and there's just so much you can do with it. I started working for STEM for Success about the same time as Natalie in November of 2019. And back then, pre-COVID times, we would go visit school, help out with events on campus, and have a lot of fun working hands-on with girls in different clubs to help promote STEM and provide different demonstrations and help lend some of our knowledge. Because of COVID and all the stay-at-home orders, I've also been working with Natalie to lead the video project series, similar to what you're seeing today with making all the different videos. So being a mentor has been a really great experience and a lot of fun to help encourage and see the enthusiasm for STEM in the younger generation. And I really like being able to pass on a lot of the knowledge I've learned over the years to younger kids. So it's been pretty great. So now I believe we're going to be transitioning to our first video for you guys. So the first video we're showing for you today is the Cooking with Chemistry, the Science of Making Bread.
Hi, I'm Emma Hamza, and I'm one of the mentors at STEM for Success and a sophomore chemical engineering student at NJIT. Today, we're going to be talking about something that's very simple, but has very complex reactions and processes when it's being made, and that is bread. Bread is an incredibly versatile and useful food. It can be used to make many different things, from sandwiches to French toast to making croutons for some salad, or even just enjoying it on its own. Just looking at a slice, It's hard to believe that most loaves are formed with only a few ingredients. The complexity of bread comes down to the steps in the bread making process and the science within those steps. So let's break it down. Most types of bread need at minimum these 5 ingredients. Here we have flour, water, yeast, salt, and sugar. Other things can be added to change the flavor or the texture, but the main chemistry lies within these simple ingredients. The most important ingredient we have here is the yeast, which is what makes the bread light and fluffy. So what is yeast and how does it work? Yeast is a tiny little organism that is used in lots of different foods, but it's most commonly known for being used to make bread. When you get yeast from the store, it is dried out and dormant, kind of like it's sleeping. To get it to work, you need to wake it up. This can be done by putting in some warm water. The warm water hydrates the yeast and gets it up and moving around again. Now that it's awake, it's going to be very hungry. This is where the sugar comes in. Once the sugar is added, the yeast begins eating the sugar and digesting it to create carbon dioxide in a process called fermentation. You can see this happening when the mixture of yeast, water, and sugar starts to get foamy with bubbles. So now that the yeast is up and ready to go, we need to add the flour, which is the main ingredient in any type of bread. When you add the flour to the water, the flour undergoes a chemical reaction and starts to transform. The flour and the water mixture becomes the dough through a process called hydration. If you were to zoom in super close on the dough, you would be able to see the water molecules interacting with protein molecules in the flour. The water molecules bind together 2 different protein molecules to create gluten, which is what makes the dough sticky and stretchy. The hydration process takes a while, so the dough is left to sit in a warm area to absorb all the water and also to start to rise. The act of rising occurs from the yeast producing more carbon dioxide, which is not getting trapped by the dough and causes the dough to expand. After the dough rises, you will be able to see all the bubbles and bubbles that have been formed in the dough. Next, you need to knead the dough. Kneading the dough gives it shape and structure through the formation of a gluten network. This can be more easily demonstrated with some string. After absorbing all the water, the gluten proteins are slightly overlapped, kind of like the strings on the stable. Before kneading, the gluten network is very thin and has lots of large gaps in between. As you knead the dough, the gluten starts to overlap more and more, like layering on pieces of string. This creates a much denser, mesh-like structure known as the gluten network. This network of gluten gives the bread its shape, so it's able to stand tall and holds all the gas bubbles produced by the yeast. So now that the dough is made, how does it become bread when you bake it? When you initially put the dough in the oven, the warm oven makes the yeast continue to produce carbon dioxide gas, which makes the dough rise even more. However, as the temperature inside the bread continues to increase, the yeast eventually dies and stops producing gas. The gluten and other proteins inside the bread will also begin to harden, and the dough will solidify into a loaf of bread as it continues baking in the oven. After putting in all the work and waiting for hours, you will be met by a nice and delicious loaf of bread. And when you cut into it, you'll be able to see all the little pockets of air that were created by the yeast, which gives the bread a really nice and soft texture. I hope you enjoyed this video and that you try making bread on your own sometime. It's really fun. Thank you for attending today's event, and as you go, remember, STEM is in everything that you do.
So now I believe we're going to start taking some questions from that video. So now's the time if you have any questions, if you're watching along, click the link down in the bio and start submitting your questions.
We'll make sure to answer all of the questions at the end, but feel free to start submitting them right now. And after that, we will now go into our next video, which is cooking with chemistry caramel. So in this video, we're going to show the exact steps that lead you to making caramel from all of the basic ingredients. So you're going to see the process of how it's made, and then you will also see the science behind everything.
Hi everyone, I'm Natalie from STEM for Success. Thank you for joining me in STEM in Your Homes Cooking with Chemistry. Today, we will explore how a chemical reaction makes caramel. Before we get started, know that this experiment entails high temperatures and the use of sharp knives, so be careful when making it. As always, we are going to start by washing our hands since we will be working with food. To make the caramel, you will need 1 cup of sugar, 1/2 cup of heavy cream, 1/4 cup of corn syrup, 1 candy thermometer, 1 stick of butter, 3 tablespoons of water, a few pinches of salt, a 3x3 baking pan, 1 can of nonstick spray, parchment paper, and 1 pot to cook the caramel in. Gently roll out your parchment paper and then cut it to fit the size of your pan. Lightly spray the nonstick spray into the bottom of your dish. You can then lightly spray your piece of parchment paper and then place it into the dish. By doing so, we're making sure that the caramel that we cook will not stick to the bottom of the pan. Then, cut your stick of butter into small squares and then combine it with your heavy cream. We are now going to microwave this for 2 minutes. Every 30 seconds while you're microwaving, make sure to take out your dish and mix the butter and heavy cream together. Turn the heat on your pot up to medium. After doing so, you can then add your water and corn syrup directly to the pot. Once they're added together, make sure to mix them together well enough so that they're perfectly combined. Once it looks combined enough, you can then add the sugar to the pot. Be careful when adding the sugar so that you don't get any on the sides of the pot because this will cause it to burn. Continue to mix all 3 of the ingredients together until they're all well combined. Now that your mixture is starting to heat up, you can now add your candy thermometer to the side of the pot. Heat the mixture over medium heat until it begins to boil. Continue to stir to make sure that everything stays smooth, either with a spoon or with your candy thermometer. Once it comes to a boil, give it one last stir, remove your candy thermometer, and cover the pot with a top for 1 minute. Once you remove the top, you're going to see that your candy is still boiling. Put your thermometer back in place and continue to stir. Continue to stir and cook your sugar mixture until it reaches 320 degrees. You should notice that the color starts to turn a light brown color. This is showing the chemical reaction happening right before your eyes. Once it reaches this temperature, you can then add your mixture of butter and heavy cream. Cook the caramel until it reaches between 230 and 240 degrees Fahrenheit. Make sure that you keep stirring, or else your mixture may start to burn on the edges, like mine started to do. The closer you get to your 230 to 240 degrees Fahrenheit range, the more you're going to notice that your mixture is going to continue to turn a dark brown color. Now that we finally reached our temperature range, it's time to turn off our stove and remove our pot. Once everything is turned off, put on your oven mitts and gently pick up the caramel, being very careful since the temperature is very high. Then you can go over to your pan and pour it right into the mold. Our caramel is now going to sit and cool down for at least 2.5 hours. After 30 minutes, you can add the salt, but you should wait an additional 2 hours before starting to cut into the caramel. You can now easily remove the caramel by lifting up the parchment paper and putting it onto a cutting board. Now that our caramel is all done, you can cut it however you would like to. I decided to cut mine into small squares and then wrap it up in wax paper, but you can do it however you would like to. Now that our caramel is done, we're going to talk more about the science behind it. So how exactly did all of our ingredients turn into caramel? Well, the easy answer, it was chemistry. This is a chemical reaction that we call caramelization. This is when sugar reacts with heat, creating what we know as caramel. There's a change in the color, the taste, the smell, the texture, and the chemical makeup of the ingredients. There's a very similar chemical reaction in food known as the Mayard reaction. This reaction is similar in that it's sugar and heat, but there's also protein that react. This creates browning on food. Some more examples of both caramelization and the Mayard reaction is something like cooking chicken, roasting vegetables, grilling burgers, as well as toasting bread. Thank you for watching Cooking with Chemistry. brought to you by STEM for Success. Hopefully you guys learned something today, and hopefully you also realized that there's science in everything that we do.
Thank you. So as you guys saw in the video, chemistry and science is in pretty much everything in our lives. The chemical reactions are especially important in cooking. So for many foods, when you add heat, that chemistry of the food will actually change like it did for the caramel. This chemical change gives the original ingredients a new taste, color, smell, and texture. As you saw in the video, caramelization is when the sugar's chemical makeup changes because of the heat. So that is the chemical reaction we're seeing. So after that, we are now going to transition to our Q&A, and Joelle is going to be leading that.
So one of the first questions we have is it hard to obtain all the things that you want to make caramel?
No, definitely not. So sugar is, and so it was sugar, corn syrup, heavy cream, and then butter. So in most supermarkets, you can find that. The corn syrup might not be at very small locations, but if you go somewhere like Walmart or ShopRite, it should be pretty easy to find the corn syrup.
And then a follow-up question to that, which how does the whoa sorry, the computer just went crazy. But does the recipe always come out as you intend it to be all the time, or will there be any difficulties during the baking?
Yeah, that's a really good question. So as I explained in the video, when you add the butter and the heavy cream to your boiling sugar, you want it to be between 230 and 240 degrees. And that's because if you cook it a little too high, if it surpasses that, then once your caramel cools, it will be very hard. And it'll be almost like a candy cane level of texture, that it's breakable, it's not very chewy, and it's definitely a lot harder to eat. And another thing that you might come across with the caramel is if you don't stir all the ingredients well in the beginning, then there's a chance the sugar could crystallize, which would make it kind of crunchy, not as smooth of a texture, make it a little bit unpleasant to eat. But other than that, as long as everything stays between the temperature range and everything's mixed, it should come out just good.
Next question is there any alternative ingredients to either of the videos?
So I'll start with this one. With bread, there is actually a lot of different potential recipes and different variations you can do. So the one I provided and that I linked to in the lesson plan that I created is a very simple loaf, but you can alternate through different types of flour, say whole wheat flour versus white flour. You can add other things to it, such as milk, butter, or oil to add more flavor and to change the texture of the bread.
And for the caramel, a few alternatives that you can do is if you're looking for a sugar-free alternative, then you can substitute the sugar for a kind of sugar substitute like stevia. If heavy cream is a problem, you can substitute it with 3 parts milk to 1 part butter. And yeah, that's pretty much most of the things you can make changes for. I believe if you were looking to make it, say, vegan, where it was not including any animal products, then a butter alternative such as vegan kinds of butter, you can use that. And for the cream, something that's similar, like coconut milk.
And another thing with there are also similar different variants of caramel other than what Natalie made in her video. So there's other recipes you can find online that have different variations as well.
Yeah. The next question was if there was any sugar-free alternatives, which I think Natalie already answered already. So we'll move on to the next question. Where did you find these ingredients and the directions to make these?
So I'll start for the caramel. So for all of my ingredients, I got them at ShopRite. I believe most larger food chains should have all the ingredients. I also did check in a local grocery store in my town, IGA, and they also had everything I needed. Sorry, what was the second part of the question?
Like, where do you find the directions to make these?
So in my video, it also includes the directions, but if you guys can access our page, it has a link to all of the steps that are included in both of our videos.
So for mine, I do a lot of research prior to my videos. So the recipe I chose, I linked back to the original recipe in my instructional plan, but I also did vary a little because I've been making bread for a while now, especially during quarantine. I know it's a hobby that a lot of people did pick up. So a lot of these things also come with a bit of trial and error over time. So you learn how to like ingest ingredients and what to add or what to take out as you experiment more with cooking and baking.
All right. So our next question is, if you could make any changes to your next videos, what would you make next?
So for me, a definite change is going to be adding closed captioning to the video. I do know that there are certain softwares that can generate the closed captions, but sometimes they can be a little faulty. If there's any like background noise like music, it might warp the actual words. So that's going to be something incorporated in the next video.
Yeah, I agree. We're working on getting closed captions onto all of our videos and different ways of doing that. And we want to expand with the Cooking with Chemistry series. So if anyone has any suggestions that they'd like to of things they'd like to see, you can also throw that in the Q&A. And we are also going to be doing some other videos involving food, hopefully for STEM month.
I think that question was questioned more towards like what else would you want to make too. So I don't know if you want to answer that question still.
Definitely something along the lines of like cupcakes and stuff because it's similar to bread, but there's a lot more chemical reactions. Or another video that's really interesting is a similar chemical reaction of cooking an egg. And can you uncook an egg? Because that's an actual question that's been asked to the scientific community for years. And they actually kind of do have an answer that yes, you can, but it's really hard to do.
And definitely another thing that we hope to explore once we are almost done with our Cooking with Chemistry, we plan to continue it with our final DNA extraction from fruit. So you can actually see the DNA being removed from fruits like strawberries and bananas. So we're going to cover that in a future video as well.
All right. So I guess the next couple questions. One person asked, do they allow you to cook this at?
So, no, unfortunately, within the labs on campus, you're not allowed to have any food or drink. That is just a basic lab protocol for any kind of lab that you're in, because when you're running experiments, you don't want any possible contaminations or anything happening. But in the campus house that Natalie and I both live in, we do have a very big kitchen. So we take advantage of that a lot and do a lot of cooking in there. So we do cook on campus, just not in the labs.
All right. That isn't really a question, it's just a comment. Really great job on your videos. Really loved it. So thank you for that person.
Thank you,
We
guys.
appreciate
Appreciate
that. We
it.
work very hard on these videos and to bring it to you. And the other question is it hard to understand the chemistry or the chemical compounds that goes along in foods? In other words, the ones that you just made.
So for my video for the caramel, the actual chemical reaction of caramelization is very complex. I definitely gave a simplified version of it, but some chemical reactions are a lot easier to see. You have this compound plus this compound, and it creates this. But with caramelization, there are so many variants of compounds that are created. So specifically in the caramelization that you guys saw in my video, there are different compounds created that contribute to the different taste as well as the different color of the caramel. So even in the scientific community, caramelization is a very, very confusing, in-depth kind of reaction.
Yeah, sorry, Joel, could you just repeat the question again?
Is it hard to understand the chemistry and or the chemical compounds that goes along with the foods?
Okay, thank you. So sometimes it can be overwhelming when you're trying to understand something on a larger scale. So it definitely helps to break it down, and like I did the bread video, is break it down into the different steps and see what's going on in each individual step. So especially also as you go through more science classes and you get older, and you learn more trying different things, it's easier to accumulate that kind of knowledge. It makes it a bit easier to comprehend certain things. So for Natalie and I, it's not as difficult, and that's why we are trying to help break it down for you guys so you can also understand as well. And we do things like drawing on the whiteboard or the different animations, so you can see things that you normally wouldn't be able to see, like with the animation, seeing things that would be on a microscopic level, but simplified to animation. So it's a little easier and kind of more cost effective to do than buying a microscope.
I wanted to come in with a couple questions from our form. One was, do you need to have the salt in the caramel and I guess in the bread? And then the other one that came in, which is sort of related, is there something different between a candy thermometer and a regular thermometer? And where do you get a candy thermometer?
Yeah, so pertaining to the first question about the salt, so if you don't want to add the salt, that's totally fine. I added it because I personally enjoy the taste, but also when you add the salt, it actually helps you taste the sweetness a little bit more in the caramel. So if you don't like it very sweet, then maybe it might not be the best idea to add the salt, but it is also optional. You'll still have a great tasting caramel. And for the candy thermometer, in terms of like why you would use the candy thermometer, what I've noticed is using something like a meat thermometer where it is just like a metal skewer, it's a lot easier to just clip the candy thermometer on the side of the pot. And it also seems like it's like long enough for it, because for me, I have like a meat thermometer and it's like only about like 3 inches long, so it wouldn't be able to reach it in my pot. And I got mine also from a local supermarket, and I'm sure if you go somewhere like Walmart and ShopRite, you would also be able to find them there.
Yeah, candy thermometers are also specifically made for candy making, so they can withstand super high temperatures for long periods of time. And also, many different types of candy thermometers will also have a bunch of different notations on them, so you can see there's different stages of candy making, and they notate the higher temperatures for that. And then for the salt in the bread, salt in bread is kind of crucial. I've made bread before where I've forgotten salt. It doesn't taste as good normally. So I would say for the bread, it's a little bit more crucial. It does have an effect on the chemistry of the bread. It slows down the yeast reaction a little bit, actually. So the yeast isn't overproducing, but it also just mainly is there for flavor.
Jim, if you have any other questions on that form, that would be the time to say, because for some reason my internet is kind of funny with the blizzard going on. I apologize.
So 2 other questions from the form. One of them specific, one of them more general. So the specific question from Cadel was, is there a way to make the process go faster, like to get the caramel sooner or get the bread baked? And then the other question is there an explanation? Is there a scientific explanation for everything you make?
So there are potential ways to make it go faster, but especially with certain things like bread and caramel, you want it to take time because some of these chemical reactions take a long time. Different chemical reactions happen at different speeds, and you need them to allow the time to complete that reaction so you don't end up with like a weird tasting caramel with like a bread that has the wrong texture. So some of these things, you learn a lot of patience in making them. And for the other part of the question was, is there a scientific explanation to everything you bake? Yeah, pretty much. Anytime you start looking into why something happens, you can apply a different level of understanding to it in the different fields of science. And the fields of science are always overlapping. So the more you look into something, the deeper you go into it, the more layers you unveil, per se, the more you will understand that you can explain everything either through chemistry, physics, and in the baseline, most everything could be explained with some sort of mathematic equation.
Yeah, definitely. And for my video specifically for the caramel, I have made caramel a few times, and I do know that if you want it a lot faster, you can up the temperature, but you do risk burning the sides of your pot. Mine did burn a tiny bit on the sides, but I've tried to cook it on high heat before, and it did make the caramel fast, but it did also permanently damage my pan. So I would not recommend doing it more than about a medium level of your flame. And as Emma was saying with our scientific explanations, obviously in the scientific community, there's always certain things that are still being explored that haven't been explained yet, but we definitely want to choose certain things that are already discovered or already explained, so that way we can break it down for everybody and make it more understandable.
Okay, some suggestions and questions also following up. One is, can you make caramel bread? And then as a suggestion, they said, how about Rice Krispie treats, maybe with chocolate? So that's those two. And then the actual questions you may want to answer is, what happens if you skip a step? Is there a way to make up for it, or, do something different if after you've done something like, oh my goodness, I left that out or I skipped that step?
Yeah, so to answer the caramel bread first, you can definitely mix different things in. Like there's certain types of bread that have like chocolate mixed in, or if you want to get more towards a dessert kind of bread, there are like different puff pastries and little desserts that can be involved with that. So there's a lot of different variants of bread, like I said in the video. And we could definitely look into making Rice Krispie treats and figure out what kind of scientific explanation could go with that. So, Natalie, if you want to talk about maybe missing a step in caramel.
Yeah, of course. So there aren't many steps in the caramel making process, but the only things I can imagine being skipped would be if you add the butter cold or the heavy cream cold into the already heated sugar. So one issue with that is that your heavy cream may curdle since it is dairy, and changing the temperature too much could affect the texture of your caramel. And if you were to skip something, as maybe you let the caramel heat too much before you added the caramel, not the caramel, you added the heavy cream and butter, then you could run the risk of the texture also being kind of off, or it could create something by letting it get too high. It can already create something that's already hardened, like I was saying with the candy cane. So it's best to just make sure you stick to it. If not, you can still add your stuff if you add it a little bit late. It may just affect the texture a little bit depending on how high you heated it.
Yeah, so bread has a little bit more of definite steps in the bread making process. So there are like kind of quick fixes you could do. Say if you forgot an ingredient, you can kind of add it in, say if you're kneading or something. One of the more crucial steps is the rising of the bread, or called proofing. And something that happens is you can over or underproof it. If you underproof it, you just let it rise a bit longer. But if you overproof it, it can come out to not rise in the oven and then become very dense. So you can kind of fix that a little by kneading it. But bread's a bit more temperamental in terms of needing kind of exact measurements and exact steps.
All right, I think we have time for maybe one more question if we have, Jim, and then we should move on.
Okay, this is a more general question, and it's sort of snow and school related. What's your favorite STEM experience related to snow or just in general?
I would have to say one of mine would probably learning how to make a quote unquote like fake snow. Especially as a kid, they sold it in a lot of like STEM kits when I was little. But there is this material that can absorb like up to 10 times its weight in water. And that's the material that if you've ever seen fake snow, how to make it. And it's really cool to see how material can just like absorb all this water. You can like pour cups and cups on it and it just dries up like instantly and then gets fluffy and you can play with it even like in the summer. So it's a fun experience to have.
And one thing that I've done that may not seem as fun, but I definitely enjoyed it, was testing snow. So people might not realize it, but snow is very dirty even before it touches the ground. So I did a little science experiment where it involves collecting snow and seeing how pure the water was. even if it was snow that didn't even touch the ground yet. And same thing with icicles. So make sure you're not eating snow or eating icicles because they are very dirty.
I was gonna say there are some recipes involving snow. If you guys are interested, I know off the top of my head, maple candy is one where it helps affect like the crystallization of the candy. So if that's something you guys are interested, let us know while there's still snow on the ground.
Remember, warning, don't try this at home. Snow falling from the sky, rain falling from the sky, the first thing it does is clean the air. So if there's pollution from cars or pollen from trees, the first thing that happens is the snow pulls it to the ground. So don't take snow off the ground. Don't take icicles. Clean snow you can make in your freezer, in your, if it's really cold out, you can literally throw up water and it'll come down as snow, but don't eat snow. That's your friendly professor, environmental scientist saying, at least in New Jersey, it's dirty for days.
Yes, definitely.
So I don't know, do you guys have other questions related to that? Or Joelle, did you want to share your STEM and snow experience?
I have no I have done no science experiments with snow besides the fact since I shovel the snow, it's always to keep track of how much snowfall at night. That way if you have for every 30 minutes or every hour or something, or else you're gonna be shoveling a big pile of heavy snow every time you go out there. So good thing you gauge that one day.
And that's important to know how cold it is, because like I didn't go shovel last night because it was so cold. All the snow was blowing around. If I shoveled it, it would just blow back. Today it's warmer, so it's all wet, doesn't go anywhere.
All right.
So the other question that just came in was, can you guys make gum or marshmallows? And I think that's like a two-part question. Like, is that something that is just you do at home, or is that like an industrial thing? And then is that something maybe we'd want to investigate? So I don't know how much you guys know about polymers of gum or marshmallows.
So I can help answer that one a little bit. Gum is a little bit more complicated to make, so we can definitely look into that one. But marshmallows are actually a little bit easier. And so we can look into getting that for you guys because it kind of is actually pretty simple. It just involves some things like sugar, gelatin. We could also look into an option that doesn't involve gelatin if you cannot have that. And like powdered sugar. So it's actually, marshmallows are pretty easy to make, and oftentimes they'll come out better than the store version. So that's definitely something we'll look into making for you guys.
So Joel, why don't you go on, and if any other questions come back, I'll let you know.
Alrighty. So real quick, right now we have STEM kits at NJIT right now. So if your club is in need of STEM kits or you guys want STEM kits, please contact us how many STEM kits you want. That way we can prepare them for you. And in terms of picking up or for us to drop this off, we can either drop it off to you or you can come by the school and we can hand it off to you there. I know Emma's there and Natalie, so contact with them. They can arrange a time where you can come by and they can hand it off to you. Or I can also drive it to your school. I know some of you already had me deliver them already to you. Any other things?
Let's stop for a second and clarify. So first of all, a STEM starter kit is meant to be a group of supplies for a group of students to work on any kind of STEM activity, hopefully that you'll use to broadcast during STEM Month 2021 in March. I know one of our coming up videos will be the unboxing of the STEM kits and maybe some activities you can do with it. If anyone is interested, just email clear@njit.edu. That's CLEAR @njit.edu, as opposed to, as Joel said, just drop by, because they won't know where to go. So if you send us that email, we'll be able to tell you where to go, and then we can arrange how to get them to you or get them mailed or delivered to you. And that's all part of this project sponsored by Howmet Aerospace Foundation and through the benefit of an NSF, National Science Foundation grant. So, all right, enough of my public service announcement, back to the work.
Well, yes, contact us first before anything happens. We have some general questions here about it. about for the STEM mentors. First is why STEM? So I guess I'll answer it first. I guess at this point, STEM has become super popular. At this point, you got to ask why not STEM? You can do many things with it, with science, technology, and then other things. You can see in many different emerging fields that STEM is becoming more and more needed, especially in this world with technology advancing and also new ideas coming about. So STEM is just a very popular thing. There's a lot of opening avenues to it. So that's why a lot of us chose STEM. Best part about being a STEM mentor really is the activities. I know when I went to Weehawken, the students there had robots that just rolled around, and they had like robot soccer where they would just crumble up a piece of paper, throw in the middle, and then the robots would be playing soccer. So it's like interactions like that that makes it fun, makes you enjoy the activities, and also makes you enjoy the subject more, really. Advice for people going into STEM. My advice right now would be a lot of people look high paying, but money isn't everything. Make sure you look at what you want to do. If you're going to be a chemist, just check if chemistry, looking at compounds, looking at molecules is really something you want to do. And you don't have to be just a chemist. There's a bunch of different professions in STEM. So try to explore what each and every one of them do and see what you like. I'll hand it off to Emma to answer. If you
So
need me to repeat the questions, I'll repeat them.
no, I think I'm good. So one of the things for why STEM, one of the personal reasons I like STEM so much, it's a way for you to like look at the world and understand it at a really deep level, and it's a way for you to explain everything and figure out a solution to everything. Especially like in my field of STEM engineering, you are creating solutions to problems and practical solutions, which is a really cool thing to do. And like the work you do can have like real life impacts on people. From that could be from like making medicine to creating different food compounds or building bridges. So it's a really cool thing that you can just have such a large impact from just having a good understanding of the world around you. And one of my favorite things about being a STEM mentor is being able to go and interact with students and teach them things and like I said before, share my knowledge. And I love seeing younger students get really excited when they're learning a new thing or get really into something, because that's how I felt when I was little. I was always like really into science, and I didn't really have that kind of STEM mentor. So I'm glad I could be there for younger students to help them, guide them in learning all the great things about the world in STEM. And one advice I'd have is, if you're interested in STEM, is don't isolate your field, yourself to the field of STEM. I personally have a lot of experience in art and music, and that makes me a better engineer. That makes me a better scientist. So definitely be involved in your community, be involved in art, learn all the different things, because it's only going to make you a better engineer. We preach a lot about getting into STEM, getting interested in STEM, doing a lot of STEM things, but don't isolate yourself to that one thing, because one thing that can happen is you can overwork yourself with that. You can burn yourself out. So make sure you are also getting a well-rounded experience and just getting to live life to its fullest, honestly. Because in the end, it'll make you a more well-rounded STEM person. So Natalie, if you'd like to take over.
Yeah, of course. So to answer why STEM, going into STEM for me was kind of like a no-brainer. I've just always been interested in science for my entire life. But as I got more into the STEM field, I kind of saw that every part of STEM, science, technology, engineering, and math, they all come together and they help you explore the unknown. And you can learn about the same exact thing, like the human body, but you can learn it from different scientific perspectives. You can learn it from biological, chemical, psychological, and so many different ways. So I just love that you can take so many different approaches to understand the same exact thing in STEM. And for me, the best part of being a STEM mentor is definitely giving back to people who can learn in a way that I wasn't able to. I came from a school district where we didn't have a lot of STEM programs in our education. Like, we didn't have any science clubs. We didn't have any kind of real push towards STEM. So I love being able to give my perspective on how it's like being in the field, what it's like getting in from a school that I came from where you don't have a lot of push for STEM, and also what it's like being a female in STEM, because it can be a very different perspective from someone who is not. So I just love that part of being a STEM mentor. And my advice for anybody that wants to go into STEM is definitely just stay curious. It can be difficult sometimes when you get lost in your classes and it seems like your main motivation is I need to get an A and I need to get a good GPA, but you should still throughout your entire education be thinking outside of the box, thinking how does this explain something in real life? Because sometimes things and concepts can seem a little outlandish and seem like it doesn't even relate to real life, but that's definitely something that you always have to stick to, is stay curious about what you're learning and keep exploring stuff like that.
All right, we're coming close to the end, but I want to answer the one question I received, which shows that people are really watching and paying attention, because I was asked, why is there a box in my window? And so I will explain that in a very straightforward way. This was set up for my daughter to do her schooling and for me to hold my meetings during any type of remote learning or things like this. And I hadn't realized that in the winter, at about 1 o'clock, if the clouds clear, the sun comes right in and focuses on the computer. So a few weeks ago, I had to put because of the angle of the sun, which most of it has never caused a problem, but apparently January and February at this time, where my house is situated, when there's no leaves on the trees, it interferes with my webcam. So that is what I wanted to explain. There's a box in my window because it's the stopgap solution for 10 minutes. I also want to make sure everyone realizes that this is going to be a regular thing. We're going to try to do it the first Monday of every month. So next March 1st, Monday, we'll have an expanded version for STEM month. We're going to try to, I believe, show some of our high school interns are going to do a piece. One of them may be on how their own rock candy. And then I know our other STEM role models here are going to do some. So I don't know if any of our students have last things to say, but otherwise, thank you for tuning in, and stay safe and have fun in the snow, because STEM is in everything you do. I'll pass it back to our MC, Joelle, and the lovely ladies who have taken care of us so far today.
Thanks, Jim. Yeah, thank you guys for coming out today. I was going to say tonight, but it's today. We appreciate you guys taking your time to watch our videos and take the time to join our stream. We take a lot of time out of our day to make these videos for you, and we hope that you enjoy it, and we hope that we answered enough of your questions too. Emma?
Yeah, so thank you guys for all coming out today. We hope that you were able to learn something in these videos and take something from it. And we hope we had a positive impact on your day. And if you have any other questions, feel free to reach out to us at the email Jim said before. And we hope to see you at our next event.
Thank you, everybody.